I would like to welcome you all in the lecture series of Sensors and Transducers. In this video, I am going to discuss most important questions from Module 1. I have referred 3 to 4 years question papers and sort out the most important question from the Module 1. So let's get started the session. First of all, we'll be seeing the question number which has happened in the year of 2018. That is a regular subject. So first question is, what is transducer? What are the advantages and disadvantages of the electrical transducers? You can refer my all previous videos. Lecture number 3, you can refer. Definitely, I have explained all the points regarding the transducers and what are the pros and cons. Now you have to explain about the linear variable differential transducers. Question number 1B, LVDT. What is LVDT? You have to explain three conditions. Okay, whenever the core is at the middle position, whenever the core is upper side, whenever the core is downside, what happened for the EMF? Okay, that you are supposed to explain with the help of mathematical equation. Now, question number 1C is regarding the capacitive transducer. So please read the question. Area has been given. Then distance between the parallel plate is provided. Now you have to calculate the value of capacitance when the dielectric is air, which is having the permeability of 8.85 into 10 to the power minus 12 farad per meter. So we can directly use the formula. Okay. Here actually you have to calculate the change in capacitance. Delta C you have to calculate. The condition has been given. Like it reduces the distance. The distance between the parallel plate has been reduced to 0.18 millimeter. Then how about the changes in capacitance? Also, you have to calculate about the changes in capacitance to the unit length. Okay, delta C divided by delta D you have to calculate. Similarly, we'll be considering the third condition if the mica sheet is 0.01 thickness, which is inserted in the gap, calculate the value of original capacitance and the change in capacitance for the same displacement. Also calculate the ratio of per unit change in capacitance to the per unit changes in displacement. Delta C by delta D again you have to calculate for the new condition. Then dielectric constant of mica is provided, that is 8. So very simple. Let's get started. I'll be showing you the solution. So first of all, what you can do is calculate the value of capacitance if the dielectrics of air is given by the permeability, that is 8.85 into 10 to the power minus 12 farad per meter. Use the formula C equal to epsilon A by D. Epsilon is nothing but the multiplication of absolute permeability and the relative permeability. Here you can see the epsilon naught is represented absolute permeability. Absolute permittivity. Don't get confused about permittivity and permeability. So this is regarding the permittivity. Epsilon naught means absolute permittivity. Epsilon r is not a relative permittivity. Both are given. Area is provided. Then distance is already given. These are the given value. Now do one thing. You can directly substitute. C is equal to epsilon 0 epsilon r into A by D. So you'll be getting the value of capacitance. It's a direct question, right? First part is the direct part, direct question only. Now second question is like calculate the change in capacitance if the linear displacement reduces to distance between the plate of 0.18 millimeter. Now you have to calculate the per unit change of capacitance to per unit change of displacement. So first of all, you have to calculate the new value of capacitance like this. C is equal to epsilon 0 epsilon r A by D dash. So later on, you are supposed to calculate by substituting, you will be getting new value of capacitance C dash. Now, change in capacitance is nothing but C dash minus C, new capacitance minus old capacitance. I'll be getting 1.2 into 10 to the power minus 11. Now, you have to apply the formula as per the question. The requirement is you have to calculate unit change of capacitance to unit change of displacement. That is nothing but delta C by delta D. So, if you use this formula directly, you will be getting the answer like this. So, now third one is, so again, a new dielectric material has been added, that is mica sheet. Now, the new value of capacitance, C double dash, epsilon 0, epsilon r into A by D. Here, remember that epsilon r will be varied, that is 8. Okay, epsilon r is taken as 8. Why? Because new capacitance has been added. Mica is a new value of new dielectric material, right? So, accordingly, we will be calculating C double dash. Then ultimately, the change in capacitance if the mica sheet has been added. Mica is a dielectric material. C double dash minus C you will be getting. So that is actually 7.73 into 10 to the this much of capacitance, right? So please follow systematically. Obviously, you'll be getting the right answer. Okay. So we have completed with the 3 segment of numerical example. Ultimately, the value, you can check it up, but please follow the steps. Delta C mica, C triple dash minus C double dash. All right. C triple dash is nothing but new capacitance with a mica reduced distance. Substituting the value C triple dash you can compute like this. Epsilon 0 epsilon r into epsilon 0 epsilon r into d divided by the formula is available epsilon 0 epsilon r a by d. Okay, a by d. Area is 250 into 10 to the power minus 6 meter square. So delta C mica that is equal to 9.7 into 10 to the power minus 11 farad. Ultimately, delta C mica dash divided by delta D, you will be getting the answer. You follow, please follow this procedure, you will be getting. Okay, right. Question number 2A. Explain the following parameters: sensitivity, linearity, resolution, hysteresis, accuracy, repeatability. So one sub question carries 1 mark. 1 into 6 is nothing but 6 marks. You have to write the definition, proper definition, then equation if necessary. Also some units, especially sensitivity, you can mention the unit. Similarly, if unit is available, you can mention the unit. Otherwise, it's like a unitless quantity. Similarly, there is a numerical example related to Hall angle. It is related to Hall effect transistors. First of all, I request you to note down the given data. So please note down the given data. Now, accordingly, we can compute the Hall angle. Hall angle you can compute, right? Question number 2B, I am going to show you Hall effect transistor. You can refer the topic. You can refer my previous video of Hall effect transducer. So please check the numerical example. First, your job is to note down the given parameters. So please note down the given data. These are the given data. Now you have to understand the concept of Hall angle by referring my previous video. It's already available. Also, for your reference, you can check the definition. So the formula is nothing but tan theta h, that is equal to mu into b. Mu is nothing but the mobility. Okay. So finding the mobility, how to calculate the mu? Yes, we have the formula. The resistivity rho, in terms of rho, you can compute the mobility. The relation between resistivity and mobility is given by rho is equal to 1 by n into E into U. Okay, E is nothing but charge of 1 electron. That is nothing but 1.6 into 10 to the power minus 19 coulomb. So please substitute accordingly. So from this, you can compute the Hall coefficient. RH is equal to 1 by NE. Okay, where RH is nothing but 1 by NE. So therefore, we can write like a mu is equal to RH divided by rho. So we are this formula you have to remember. Important formula. Mu is equal to RH divided by rho. Rho is nothing but resistivity or specific resistance, right? These are the like equation we are supposed to solve this numerical example. Now it is your job will be completed. Mu can be computed. R is given. Similarly, RH. See, Hall coefficient is nothing but RH, which is directly given. Okay. Then rho is already provided. Rho is 0.00912 ohm meter. RH is nothing but 3.55 into 10 to the power minus 4 meter cube per coulomb. So please substitute accordingly. I'll be getting mu. Once you get the value of mu, you can use the formula tan theta h is equal to mu b, this one. So kindly have a note of this. This formula. Tan theta h is equal to mu b, right? Okay. So tan theta is equal to mu b. Then from this theta h you can calculate. Take tan inverse of the answer. Tan inverse of 0.018672. That means ARC, that means tan inverse. You are getting 1.07 degree. Okay, so Hall angle is equal to 1.07 degree. This is the another numerical example. I hope it's clear to everybody. So two numerical example they have asked in the year of 2018. Okay, so please follow. Definitely, you can find out the proper answer. Step is very important. Equations, how you are going to make use of the equations. Okay, hope you can follow me. Now, VTU question paper 2019 is a regular paper. So I found that all the questions are like a theory based only. For example, you can check it up. The first question is, what is transducer? How do they classify? What are the advantages and advantages of electrical transducer, which carries 5 marks? Very easy question. What is reluctance transducer? You should know what is reluctance. Reluctance is nothing but L by mu A. So if you know this concept, reluctance is directly proportional to air gap length and which is inversely proportional to area. So if you know this concept, you can easily explain the reluctance transducer. So altogether, 15 marks from module 1. Here you can see like explain the working of piezoelectric accelerometer. List the advantages, disadvantages, and applications of piezoelectric accelerometer. You should know about, you should have a better idea about piezoelectric crystal. So based on the idea about the piezoelectric crystal, you can directly apply here and you can compute, you can elaborate what is piezoelectric accelerometer. Also, you can explain the working of LVDT. It's a very, very important question. In the previous question paper also, I have seen the same question paper. I request all the candidates kindly have a note on LVDT. Very, very important. It is most important question which you can expect in the next examination also, forthcoming examination also. LVDT. So there are two type of LVDT, RVDT and LVDT. Okay, rotary variable differential transducer or linear variable differential transducer. Both are important only. I request everybody to focus LVDT with the help of diagram. I have already done a video on this very long back. I request you to go through the same video in the playlist. Explain the displacement measurement using Hall effect transducer. Just now we solved the numerical example. Okay, same concept you can apply for explaining the theory of Hall effect transducer. Write down the equations as well. I have explained the equation. First of all, what is the main requirement is write the important points. What is Hall effect? How does Hall effect transducer operate? And what is Hall angle tan theta h? Okay, how will you compute the tan theta h? What are the major parameters which are affecting the Hall angle? Similarly, you have to explain with the help of a simple circuit diagram or simple block diagram. These are the things which we are expected whenever we are doing the valuation. Okay. So in that key, they will be mentioning like a diagram with explanation, equations, expressions like that they are going to mention, right? So you should be capable of facing or you should be capable of adopting those key points in your answer book. Otherwise, you cannot get the expected marks. Question number 2020. Question number in the year of 2020, this question paper is question paper has been happened. So what are the advantages and disadvantages of electrical transducer? So found that this is also one of the important question. What is transducer? What are the advantages and disadvantages of transducer? You can refer my second video. Definitely I have explained. I remember I already explained the same concept in my first or second video. We can refer this. Other one is what is piezoelectric effect. Okay. Explain the working of piezoelectric device. Piezoelectric crystal you can explain. Example, piezoelectric accelerometer. Explain the construction working of piezoelectric accelerometer. Very simple. Weightage is 6 marks. So you divide what is piezoelectric crystal effect? 2 marks. Explain the working of piezoelectric device, another 2 marks. Explain the construction working of piezoelectric accelerometer, 2 marks. Please restrict your answer because marks is only 6 marks. 2 plus 2 plus 2. That will be the way of giving the answer key. I request you to respect the time as well. Other one is related to the numerical example of linear variable differential transducer. So here you are supposed to calculate the sensitivity of LVDT and the resolution of instrument in millimeter. Unfortunately, the weightage is very less. It is 2 marks. So I request you to within half page you are supposed to complete. Within fraction of 5 minutes you are supposed to find up this answer. So you have to calculate the sensitivity of LVDT. Second one is resolution of the instrument in terms of millimeter. Let us directly move on to the answer. It is very simple analytical type question, but unfortunately they have given very less marks. Okay, yeah. Here, first of all, your job is to note down the given data. Everybody please focus on this. These are the given data. Okay. Similarly, sensitivity of LVDT. Okay. So what is first of all, to calculate the sensitivity, what you are supposed to do is actual output voltage from the LVDT to be computed. Formula is output voltage of the voltmeter divided by amplifier gain. Output voltage is directly given. Amplifier gain is also provided. Look at this. Amplifier gain is available. Amplification factor. That is called amplification factor. So output voltage is also given 2 millivolt. So try to convert in the SI unit and with respect to the calculation you need to make out. So therefore sensitivity will be 16 microvolt per millimeter. So this is called the sensitivity of LVDT. That was the first question. Very simple. Direct division, if you take the ratio of output to voltage to the amplifier gain, obviously you will be getting sensitivity. Later on, resolution to be computed in terms of millimeter. First of all, the voltage per division of the voltmeter to be calculated. 50 millivolt per division. Voltage corresponding to 1 by 5th division will be equal to 1 by 5 into 50 millivolt. That is 10 millivolt. So amplifier gain, okay, amplification factor that is 250. Then actual change of the LVDT output corresponding to 1 by 5 of the voltmeter. So what you are supposed to do is you have to take the ratio of 10 millivolt to the 250. 250 volt is the amplification factor. Okay. So what you are going to find the corresponding displacement, we use the sensitivity. So displacement is nothing but voltage change at LVDT divided by sensitivity. So voltage change, we got it as 40 microvolt. So how did you get the voltage change? So 10 millivolt. 10 millivolt is nothing but voltage corresponding to 1 by 5th of the division to the amplification factor. Then displacement is nothing but voltage change at LVDT divided by sensitivity. Of course, you will be getting 40 microvolt by 16 microvolt per millimeter. You will be getting 2.5 millimeter. Therefore, resolution of the instrument is equal to 2.5 millimeter. Please follow the steps. Obviously, you will be getting the answer. Ultimately, the resolution of the instrument in terms of millimeter is 2.5 millimeter. Hope you can follow me. I request you to practice once. Already answer is available. You can just check it up. I just provided a hint how to get into the numerical example. That was the major intention. So I have gone little bit fastly. However, you can all the materials are available. You pause this video. Please make a note of this and come to the answer. Right. Steps are very clearly I already explained. Question number 2A. What is photoconductive and photovoltaic cell? Both are working as just like opposite only. 2.5 plus 2.5 marks. Diagram with a brief explanation is expected. If you have any relevant equations, try to highlight the equations as well. They will give the weightage. What is Hall effect? The definition of Hall effect you are supposed to explain. Explain the displacement measurement by using Hall effect transducer. So 2 plus 3 marks. 3 plus marks for displacement measurement using the Hall effect transducers. So in that you need to explain about tan theta h. How will you compute the tan theta h? Similarly, this question I think you are remembering. In the last year, they repeated 2018. They have repeated the same question. I request you to recall the answer once again. I will be showing you. If you want, I will be showing. Question number 2C will be available here. Question number 2C. Yes, this is question number 2C. Okay. So given data, all the parameters, capacitance calculation, epsilon 0, epsilon r into A by D. That is the generic formula. Accordingly, parallel plate capacitance formula is available. How to calculate the capacitance of a parallel plate capacitance? Here, capacitance is directly depending on the area of the plate and inversely depending on the distance between the two parallel plates. So that's a key concept. Later, some changes, how to calculate the delta C, how to calculate the delta C by delta D, how will you calculate the delta C after adding the new type of sheet. Like here, they have given like a mica. Mica is a new type of dielectric material. Similarly, again change after adding the mica capacitor, what could be the changes in the capacitor? New capacitance minus previous capacitance. There are so many cases also. Now, after computing the changes in capacitance after inserting the mica, divided by change in length, you are supposed to calculate. So it varies with respect to the type of dielectric material. So here there is a table which shows as soon as you keep the dielectric medium as air, the value of capacitance is different. If you keep mica, the value of capacitance is different, like that. So make it sense. I think you will follow. Okay. Just make your like a normal common sense. That's all. Okay, that is 2C also cleared. Okay. Now we have another question paper. So look at this. Yeah. Explain the classification of transducer based on the power requirement, type of output, and electrical principle. They mentioned 3 criteria. So 3 into 3, 3 plus 3 plus 3, 9 marks you will be getting. So 3 criteria, you're supposed to do the division. In this regard, I request you to refer my 5th video. 5th video is based on the classification of transducer. Before that, I request you to go through the playlist of sensors and transducers. I have given the in-depth analysis of in-depth overview of the subject sensors and transducers. Briefly explain the operation of linear and angular motion potentiometer with a neat diagram. So 3 plus 4 marks you'll be getting. Otherwise 3 plus 3 plus 1, 1 for diagram. Similarly, platinum resistance, problem on the RTD. Okay. The value of resistance and the temperature is given. Temperature coefficient alpha, that is also provided. Now you have to calculate the resistance at 50 degrees Celsius. You need to calculate the value of temperature when the resistance of the RTD is 200 ohm. Okay. So this is another simple question. So you can, if you solve it, you will be getting very good marks. 7 marks will be getting. So 3 plus 4 marks, 7 marks will be getting. 2A, let us see how to solve this. I request you to note down pen and paper. So very simple formula you are supposed to note down. So new value of resistance is equal to old value of resistance into 1 plus alpha into T2 minus T1. This is a standard formula which I mentioned here. So given data you are supposed to note down. These are the given data. So now new value of R2 will be computed. So based on this formula, you please compute the new value of resistance. R2 is equal to 10098.05 ohms. Definitely you will be getting the 3 marks. Now let us work on another 4 marks. How to earn another 4 marks? Okay. So what was the question actually? If the temperature has the resistance of 200 ohm, calculate the value of temperature. So here the T2 you are supposed to make out. From this formula, please separate the value of T2 using the mathematical rearranging the formula. So now T2 will be computed based on this. So ultimately we'll be getting 280.33 degrees Celsius. So I can surely say that it's a direct straight away questions. There is no twisting, no analysis required. But in the previous problem, I think some analysis is required. You might have familiar the previous problems also. So some common sense, some logic is applied. But here, if you know the formula without thinking anything, you can reach the answers. Question number 2B, with the neat diagram, explain the working of capacitive transducer. We have already solved the numerical example of capacitive transducer using the formula C is equal to epsilon 0, epsilon R, A by D. So now we are supposed to explain the theoretical concept. What will happen when the area of the plate will be changed? So we will be getting like a value of capacitance. Capacitance and the area is directly proportional. If the distance between the plates that is inversely proportional to capacitance. If the distance between the plate is very high, capacitance comes down, right? C is inversely proportional to D. That concept also you have to remember. So these are the important questions from 2019. Okay. Now there are some questions on 2023, which has happened very recently. So very quite interesting because I found that all the questions are theory only. It is pretty easy for me, for you people. With a neat diagram, explain the strain measurement using the resistive strain gauge. What do you mean by strain gauge? That concept you are supposed to explain with a neat diagram explanation with the relevant equations. Explain the working of laser interferometer with a neat diagram. Okay, check the syllabus accordingly, you can plan the answer. Then write a short note on like distance traveled in 3. Explain the drag and drop method, rotary form of LVDT, RVDT. So these are the important questions they asked in the year of 2023, which is recently happened. You please verify the syllabus also. In case the same content is not available in the syllabus, at the time of valuation or at the time of moderation, they are going to give additional marks. It will be beneficial for the student community. Apart from that, I listed out the important questions which may ask in the forthcoming examination. Define transducer, explain the classification, advantages and disadvantages of the transducer. What is thermistor? Okay, there are positive coefficient of resistance and negative coefficient of resistance that you have to explain separately with a graph. Discuss the operation of self-generating type of variable inductance transducer. What do you mean by variable inductance transducers? Similarly, what is LVDT? Explain the pros and cons. What is a capacitive transducer? I request you to draw the diagram with the suitable equations. What is piezoelectric effect? Explain the operation of piezoelectric accelerometer. This is most important. Explain the current measurement or magnetic flux measurement using the Hall effect transducers. In that, the equations are most important. With a neat sketch, explain the working of piezoelectric transducers. Similarly, this numerical example related to Hall angle, we already worked out. I request you to compare that particular numerical example with the question number 10. Question number 10 is this question only. So you can make a comparison, compute the Hall effect. Hall angle you are supposed to compute. Now I am concluding the session. In this video, I discussed the detailed questions which you can expect in the forthcoming examination from module 1 of sensors and transducers. Let me know if you have any queries. You can pause this video and you can check it up once again. Still, you cannot make it. You can directly mail me. Okay. So I'm going to answer with respect to the comments which received in the comment box. Thank you so much for watching this video. I wish you very happy learning and have a great day for everybody. Thank you all.